A relationship is the price you pay for the anticipation of it. How's that for a grim worldview? Go figure, this guy had what a string of disastrous relationships, but what you see here is introduce a maybe, and it is very, very powerful. One final piece of the dopamine system here that is pertinent, which is, as you might expect from all of our molecular biology stuff, there's all sorts of different dopamine receptor subtypes. And two of them are pertinent to this world of sexual behavior and reward, what is called shockingly, the D1 dopamine receptor and the D2 dopamine receptor. And what studies show is in monogamous species, what happens is right after mating, when a pair bond is first formed, the second that's over with, levels of the D2 receptor go way down. You down-regulate the levels of the receptor, and you up-regulate the levels of the D1 receptor. And you flash up their picture, and the dopamine system doesn't activate. What activates instead was that anterior cingulate thing we heard about on Friday, having to do with empathy and comfort and all of that. In other words, what we see here is the neurochemical transition from one's beloved, from causing like your blood to run scalding hot, to your beloved being like a comfortable old armchair. This is one depressing study. There are sexual behavior stuff, and there's been one study showing that a higher ratio of D2 to D1 predicts more stable relationships. Small effect, not replicated yet, but nonetheless, that's kind of interesting. So on a certain level then, D2 seems to be required, at least shown in rodents. Who knows about us? D2 is about the formation of the attachment. D1 is about the maintenance of it, the faithfulness of it, if you will. And oxytocin is to females as vasopressin is to males. And we've already heard something about this back in the molecular genetic stuff and those if-then clauses and unlikely ways in which you get mutations. Vasopressin also is found in the nervous system, where it serves a neuromodulatory role. And vasopressin is critical for forming a pair bond. What's going on, what you have uniquely in the monogamous species is expression of the vasopressin receptor gene on neurons that release dopamine. In other words, males secrete vasopressin, and if you are of a species where vasopressin now goes and stimulates dopamine neurons, you decide you really, really, really liked having sex with this other vole, and you come back for more. And that's the driving force on the formation of the pair bond. Incredible studies showing that if you take male voles from the polygamous species and due to gene transfer techniques, I've mentioned this study already, but you now stick vasopressin receptors into those dopamine neurons, those polygamous males now become pair bonding males. They now become monogamous. So how about humans? And what you see is not explicitly as much genetic variability as some people having the monogamous vole version and some people have the polygamous, but nonetheless you get variation. The gene basically is about halfway in between. Whoa, we keep having that theme over and over. All these different ways of looking at body size and sexual dimorphism and imprinted genes and all that stuff. And humans keep winding up being about a halfway between a classic monogamous pair bonder and a classic polygamous tournament species. So the basic human version of it is somewhere in between. But you get variations. You got genetic variations that either look a little bit more like the monogamous vole version or the polygamous vole version. He sniffed some oxytocin. So does anybody want to guess which okay, what you now all know is there's now been a lot of demonstrations of mutations in the vasopressin receptor gene in family pedigrees with autism, a disease of very, very little attachment to other humans. And a study was done in the late 80s by a neuroanatomist named Simon LeVay. LeVay is one of the all-time great neuroanatomists. He was trained by Hubel and Wiesel, was a professor at Harvard Med School for a while before moving to the Salk Institute. And what he did was look post-mortem at the brains of a bunch of individuals where he knew the sexual orientation, men, and what he showed was gay men on the average had this nucleus on the average was half the size that you saw in heterosexual men. On the average, it was about the same size as you saw in heterosexual women. Amazing landmark study. Everybody learned about the homosexual brain from this study. Hugely widely reported, and this is kind of interesting. Okay, what's interesting about it? First off, the question you need to ask is how much variability? Fair amount. It wasn't all that reliable of a difference. On the average, it was about a half the size. Next thing you would want to know is, has anybody replicated it since then? Yes. Next thing you would want to know is, where did LeVay get the brains from? And these were predominantly from gay men who had died of AIDS. Is that a confound? Is that going to perhaps atrophy this part of the brain? Nobody knows. So that remains as a caveat in that study. What was striking, though, was everybody learned about this finding. This became famous. LeVay became extremely famous for this. And what was also very interesting about it was the political context of this finding. A few years before that, another group had reported another difference in the hypothalamus based on sexual orientation. And this was... there it is. And what you found was in this part of the brain, on the average, it would tend to be bigger in women than in men. And what these guys reported was, in gay men, it tended to be bigger than in straight men. What was puzzling about this study was this was a part of the hypothalamus having to do with regulation of like your kidneys, and it was totally ignored and completely bizarre, except there was one thing that was done with it, which was this was viewed as a totally offensive study in the gay community. This was viewed as an attempt by scientists to pathologize sexual orientation, to say, you see, we found something wrong in the brains of homosexual men. This part of the brain is bigger than it should be. It's bigger than it's supposed to be. There's probably two reasons why that occurred. The first one was that the scientists who did it were straight. And the second reason being that they were a Dutch group, and I am willing to bet unconsciously there was something Central European Nazi echoes of Germanic-sounding authors producing this finding, which there is no shortage of history in the gay community for being skittish about Nazi notions of what normality is in human behavior and human brains. This finding got widely condemned in the gay community. Out came LeVay with his finding, and he became the most beloved neuroanatomist ever in the history of gay communities. One probably important reason for it is that LeVay was gay, very openly so. Another reason was the part of the brain he found made sense. It had something to do with sexual behavior as opposed to this totally puzzling thing. So what was this about? Very interestingly, the explanation almost certainly is that this was the part of the hypothalamus next door to the area that LeVay studied. And if this part was smaller in gay men, simply because of just physical constraint stuff, this part could get bigger in gay men, because this one was taking up less area. That's probably what was going on. What's really fascinating, though, is the political context that this research was done in. And this was that first group, the senior author of it, a man named Dick Schwab, and he got death threats because of that study, reporting, ooh, here is, easily interpreted as, something wrong in the brains of gay men. And Simon LeVay became the hero in the community. This was utterly embraced by the community, because in large part how it was interpreted as This is biology. This isn't choice. This is biology. Look at this. This is ridiculous as saying, oh my God, if we have gay teachers in the classroom, we will turn the Boy Scouts of America into gay men. Oh my God, if we have blue-eyed teachers in the classroom. The usual argument that this is absolute gibberish to demonize sexual orientation as a choice. Look at this. There's a neurobiology of it. And this was embraced sufficiently that I've seen people in the Castro district in San Francisco. This has disappeared somewhat, showing the half-life of neuroanatomical knowledge. But during that time, people in the Castro district up in the city there, which is a very gay community, I have seen people with t-shirts saying the other term. People never really wanted to embrace this INAH. So its nickname was the sexually dimorphic nucleus of the hypothalamus. And I've seen people with t-shirts saying the only small thing about me is my sexually dimorphic nucleus. They were actually selling t-shirts that would say this during gay pride parades around 1990 or so. Isn't it great when people learn neuroanatomy out in the general public there? And what has been shown quite reliably since then is, on the average, gay men tend to have the finger length ratio of straight women rather than of straight men. A small effect there. Another even more bizarre finding, which is there is something called the autoacoustic reflex. And what that is if you sit there and plug your ears up with your fingers, you will hear a noise that's just coming from the intrinsic vibration of something or other in your ears. And that's the autoacoustic reflex generating some low hertz sound in there. And the rate of the oscillation differs by sex in humans, which no doubt explains everything about the tragic wars of the sexes and why people just don't understand each other by gender because of their ears vibrating at different speeds. But what these studies have also shown was gay men having the autoacoustic reflexive vibratory speed more typical of straight women than straight men. Again, a very small effect. What is the neurobiology of transsexuality? And that used to be considered to be purely a domain of psychopathology. If being gay used to be a certifiable psychiatric disorder up until the early 1970s, the American Psychiatric Association, in their textbook, the Diagnostic Statistical Manual, you could be psychiatrically certified as ill. A psychiatric disorder was being homosexual or lesbian. And then in what had to have been one of the more all-time blowout committee meetings ever, they decided that no, actually it's not a psychiatric disorder, and overnight about 40 million Americans were cured of a psychiatric disease. The notion of transsexuality as a psychiatric disorder has had much, much longer shelf life. What's the neurobiology of that? To date, there have been a handful of studies, and they show essentially the same thing. Really, really interesting. Another region of the brain that shows a sex difference in its average size. Don't even worry about the name of this. It's called the bed nucleus of the striae terminalis. It's where the amygdala begins to send its projection into the hypothalamus. Another one to those gender differences. There's one type of neuron in there with a certain type of neurotransmitter where very, very reliably it is about twice the size in males than in females. Sufficiently so that even in human brains, you could pretty confidently determine the sex of somebody by seeing the number of these neurons. You'll see I'm not even saying the name of the neurotransmitter. It's irrelevant. It's just another one of those differences, a dimorphism in a region of the brain, a really, really reliable one. And this was a study done by some superb neuroanatomists looking at transsexuals. And what they showed was very interesting, which was very, very reliably and a very powerful effect. What you would see in their large sample size of transsexuals' brains post-mortem was people would have this part of the brain the size not of their sex that they were born with, but rather of the sex they insisted they always actually were. Wow. Immediate questions one must ask. Okay, well maybe this is due to the fact that when people change gender, transsexual procedures, there's a whole lot of hormones involved, and maybe that's doing something to this part of the brain. Critical control that they had was this was looking both at transsexuals who had made gender changes and those who went to their deathbed saying, this is not the sex that I am, I got the wrong body, but never made the change. It wasn't a function of having actually gone through the transition and the endocrine manipulations with it. Another control they had, which was looking at men who would get a certain type of testicular cancer where they would have to be treated with certain feminizing hormones. In other words, very similar to some of the endocrine treatments of male to female transgendered individuals, and post-mortem, you didn't see the changes there. It has nothing to do with the hormones. It had to do with the person insisting from day one that they got the wrong body. And this was a landmark study, fabulously well done and controlled and replicated once since then, showing that what transsexualism used to be thought of is that people who think that they're a different gender than they actually are. What this study suggests is what transsexualism is about is people who got the wrong gendered body. And these are people who are chromosomally of one sex. In terms of their gonads, they're of that sex. In terms of their hormones, they're of that sex. In terms of their genitalia and their secondary sexual characteristics, they're of that sex. But they're insisting that's not who I really am. This part of the brain agrees with them. Also, very interestingly, that study was done by the same Dutch scientists who did this one. Again, this is very complex terrain in terms of what these things wind up implicating. Interestingly, that study was published right around the time that the city of San Francisco did something very cool, which was for city employees now, medical insurance will cover transgender operations. However, there's no evidence that the obscure endocrine journal published out of Latvia or something did that like the afternoon before, the San Francisco commissioners had their meeting on that one. But nonetheless, this is a subject with all sorts of realms of implications. One additional study about transsexualism. Okay, how many of you know about phantom limb syndrome? Okay. You are a guy with a penis and you get a certain type of penile cancer, and what's often done is your penis is excised, it is cut off, and about 60% of men who have had to have their penises removed because of cancer there wind up getting phantom penile sensations, which I don't want to know about. What you see, though, is when you take transgendered individuals who go from male to female, in other words, as part of it, having their penises removed, 0% rate of penile phantom sensation. Suggestion being that there is something much more normal in that case than when a penis is being removed for cancer. A whole new area of research, very novel, very challenging. Okay, so this has given us a sense now of this bucket. And we are now ready to move on to what in the environment releases some of these fixed action patterns of sexual behavior, what in the environment is doing this or that to the medial preoptic area or the amygdala or vasopressin receptor levels or any such thing. What are the sensory triggers for the neurobiology of sexual behavior? Okay. Right off, what is obvious is we are in ethologyville here. It's going to depend on the species which sensory modality is most important. And this is, once again, the crushing of the limbic system equals nose brain concept. Limbic system equals nose brain. If you were a rat, it's once again going to be interviewing an animal in its own language. You've got pheromones. And thus we enter the magnificent, wonderful world of pheromonal communication and pheromonal sexual arousal. All sorts of interesting findings there. First, at the end of generating pheromones that are sexually arousing. What is required in both species, in both species? Whoa, that was an interesting slip. What's required in both sexes? Okay, what's required in both kinds, is right hormones in order to generate pheromones, sexually arousing pheromones in all the different species. Look, that's where the species part was coming into that sentence. What you see is males do not generate sexually arousing pheromones if they lack testosterone levels. Ovary-ectomized females, women, rats, monkeys, etc., who've had their ovaries removed do not produce pheromones that are sexually arousing. What that, of course, brings up is what are some of the chemical constituents of pheromones? And this is very interesting because it brings up another one of those weird domains of neuromarketing. Pheromones that have sexually arousing components, there's all sorts of fatty acids that play a role in it, but a lot of what is sexually arousing about pheromones in different species are breakdown products of sex hormones, breakdown products of androgens in males, of estrogens in females, and that winds up providing some of these sexually arousing aspects of those odors. What does that immediately tell you? Your olfactory receptors have all sorts of receptors there that could pick up on remnants of testosterone and estrogen, things of that sort. That makes a lot of sense. What doesn't make any sense at all is the following finding, which is perfume. Perfume, in its classic form, is made out of the sweat of various animals. Okay. Except we're going to get into even worse domain here, which is perfumes traditionally, before getting the synthetic versions, were typically made from the sweat of male animals. What's that about? Musk, things of that sort. Chanel No. 5 is made from the sweat of whipped male Abyssinian cats. I kid you not, and this even produced protests some years ago, animal rights groups, about how we should not be perfuming ourselves with the sweat of whipped male Abyssinian cats. Suddenly, you've got a real puzzle. Along come synthetic perfumes, and the majority of them are made of synthetic versions of androgens. Wait a second. Perfume is made up of all sorts of breakdown products of male sweat? Isn't perfume supposed to smell good to guys? We have a deep abiding puzzle here. And there is an answer for it. Let me survey people first off. Okay, guys in the room, how many of you basically think that most perfumes smell kind of appealing? Okay, how many of you don't? Okay, females, how many of you think your basic off-the-rack perfume smells appealing? Okay, well that proves something. Okay, just to complete it, how many of you don't? Okay, the vast majority of perfumes are not purchased by men. The vast majority are purchased by women. In other words, most of the marketing decisions about what to stick in your perfumes are being marketed for people who are going to decide if it's appealing or not, people who have lots of estrogen in their bloodstream rather than androgens. That is thought to be the explanation for how it is that most perfumes are derived from male pheromones. Yeah?
Another thing is, if I were to wear perfume, it would be more so that girls think I smell good than for me to think I smell good.
Okay, yes. The strategizing starts. Okay, so a whole new world of potential neuromarketing here, but this taps into what are the chemical constituents of pheromones. What sort of information is carried by pheromones? Olfactory communication between genders. It will tell you the species of the individual. It will tell you their gender. It will tell you whether they are gonadally intact, whether they've been castrated or not. It will tell you something about their health. It will tell you whether they are terrified or not, have the sweat from someone or something that is terrified. And as we already know, it will smell differently to the amygdala. It will have a lot more glucocorticoid breakdown products in it, and it will tell you, as we know already, if it's the right species, if this person is related to you. Final point before we then go into the specifics of what pheromones are doing to the neurobiology of all this. Finally, not only do you need to have hormones intact in order to generate the pheromones, you need to have the right reproductive hormones on board in order to perceive them. Men who are castrated no longer find the smells of female ovarian, okay, I'm getting ahead of myself here. Okay, if you don't have the hormones on board, if you have no estrogen and you're female, or if you have no testosterone and you are male, you will not be able to distinguish the sweat of women and men. Gonadally intact people can at above the chance level. Finally, women become far better at detecting the smell of, distinguishing the smell of men versus women when they are ovulating. Finally, that's not what you see when you have gay individuals. Gay men are better at detecting the smell of gay men than either straight men or straight women. So we've got in the first pieces of here with the pheromonal system, you have to be hormonally intact to generate pheromones that are sexually informative and to detect them. What we will then transition to is what sort of information is being carried in the pheromones and what effect does it have on the neurobiology of depending on whose pheromones you are sniffing. Okay, so we will.
For more, please visit us at stanford.edu.